Problem number 4B. The bag contains 4 red M&Ms, and they each are numbered 1, 2, 3, and 4. Blue M&Ms, there's 3 of them, numbered 2, 3, and 4. And 5 green M&Ms, numbered 3, 4, 5, 6, 7. So I think it would be important to be able to come up with a sample space for this, to write down, try to find all the possibilities. So before we take a look at the different events, we can write down the sample space. We'll call it R1, R2, R3, and R4, and B2, B3, B4, G3, G4, G5, G6, and G7. And notice if we count all of them, it looks like there's going to be 12 total, so that's our sample space. Now let's consider events. G is when we pick a green, B is when we pick a blue, O is when we pick an odd number. So I think it would be good to find probabilities for each of these things. First one's asking us to draw a green, and so our notation there would be P of G, drawing a green. And so that's going to equal to 1, 2, 3, 4, 5. It looks like there's 5 greens out of 12, and so our probability would be 5 out of 12. For me, I prefer fractions, but if you want to type a decimal, that would be 0.4167, rounded off to 4 decimal places. Now the next one is looking for the probability that you pick a green and then a blue with replacement. So what we want to do is first we need to figure out the probability of picking a green is. We already got that. And then what's the probability of picking a blue with replacement. So let's consider with replacement first. And the notation for that, the probability of picking a blue with the replacement, well, we're going to find the probability of pick a blue provided that we've picked the green already. But in the case where we replace it, if we had picked the green and put it back, that's exactly the same as probability that we pick a blue from the beginning. And so that would turn out to be 3 out of 12. And I believe 3 out of 12 is a quarter, or 0.25. So that's with replacement. Now if we're considering the probability that we pick a green and then a blue, so that's going to require 2 steps. Green and then blue. So that's the probability that we actually pick a green, and then times the probability that we pick a blue, provided that we've selected a green first. But like I said, with replacement, it's the same thing as probability of just picking a blue. So this is going to equal to 5 out of 12. Let's put a parentheses around that. And then 3 out of 12. So that would be this number, 5 out of 12 times 3 out of 12.25, which is about 10%, 10.41. 0.1041, let's call it 42, rounded off to the 4th decimal place. Now let's see, let's do the same problem with replacement, or without replacement. So without replacement, probably that we select a blue, provided we've selected a green. If we've taken one of the green out, then your denominator would be 1 less, your n would be 1 less. You're choosing 3 blues out of 11 because we're assuming that one of the green is already gone. So it would be 3 out of 11. and 3 out of 11 is about 27.27%. And so in this case, the probability that we're going to get a green and then a blue is going to be the multiplication rule P of G times P of B, the blue, given that we'd already chosen a G. So that's green, so that's 3 out of 11. So it's 3 out of 11 times 5 out of 12. And that's going to give us 11.36%, or decimal is just 0.1136, and that should be the rounded off. Okay. Alright, let's go to the next one. What's the probability that we select an odd number? So the probability that we select an odd number is going to be, we need to count how many odd numbers there are out of 12. So that's 1, 2, 3, 4, 5, 6. It looks like there's 6 numbers that are odd out of 12. So that's 50%. What's the probability that we select an even number? Well, it turns out that an even number is equal to the complement of the odd number. Now in this case, since it's 50%, it kind of, the complement is the same, but really this is what you need to do. So it's going to be 1 minus the probability that we had an odd number. So the 1 minus 0.5, which happens to be equal to, in this case, also 50%. So our last question was the probability that you pick a green or an odd number. So we have an OR business over here, and whenever we see an OR, we think about an addition rule. So probability that we select a green or an odd number. So that's P of G or O. Let's see how to work this out. And so according to the addition rule, we look at the probability that we select a green plus add the probability that we select an odd number. Now it turns out that there are several green M&Ms with odd numbers on them, so we're counting them twice, it turns out, so we want to make sure we uncount those. So we're going to subtract out the probability that we select the green and an odd number from here. So what do we have? Probability the green is 5 out of 12. We want to add probability that we get an odd number, which is 6 out of 12. And now we got too much there, so we want to subtract out the probability that we selected a green or an odd number. There's 1, 2, and there's 3 of them right here, so we need to subtract out 3 out of 12. Whoops, let's put that over here. 3 out of 12. And so this should be it. Since they all have the same denominator, 5 plus 6 is 11, minus 3 is 8, and 8 out of 12 looks like it's 66%. Or 66.6667. So these are the probability questions.